So moving on from chain rule, product rule, and quotient rule, which are the three main rules for differentiation. So hopefully by now you should be comfortable with chain rule, product rule, and quotient rule. So if you're on, you have to do more questions. Make sure they become like a left arm and a right arm. You know, something you don't have to control. When you see a question about chain rule, product rule, quotient rule, you should be able to do it, you know, automatically. So we're going to apply those ones when we need to, whenever we need to from now on. So today we're looking into differentiating trigonometric functions. So example, we'll jump straight into example because there's nothing about, you know, notes. It's just showing you example how to differentiate trig functions. Example, differentiate y equals 10x. We don't know 10x, but we know y 10x could be rewritten as sine over cos x. Okay, sine x over cos x. And straight away, sine x over cos x, maybe you can tell me what rule we can use, apply, what rule we can apply in here. Quotient rule, okay, because you can see a fraction. So to apply quotient rule, we need to use that u equals the numerator and v equals denominator. Right, so let me move this to the right side to save you some space. And then I need to du by dx in here. The differential sine x, we get cos x. Remember that clock thing, sine, cos, negative sine, negative cos. Clockwise is derivative. The differentiating sine will give you cos, and differentiate cos will give you negative sine x. Then we can use quotient rule. So I'm going to apply in here quotient rule. Okay, quotient rule. So how can I spell quotient rule? So quotient rule is dy by dx equal v du, v cos x, times du times cos x, minus u sine x, dv times negative sine x, over v squared. V is cos squared x. We can simplify the numerator, so dy by dx, left-hand side. We keep writing left-hand side, okay, don't be lazy, keep writing left-hand side. And then top, cos x times cos x, cos squared x, negative sine x times negative sine x, positive sine squared x, over cos squared x. So hopefully you do remember by now, naturally, when you look at the top, you know it should simplify into 1. Sine squared plus cos squared equals 1. And 1 over cos squared is sec squared x. Okay. Therefore, the derivative of 10x is cos x. Now you will see, oh, not in here. Did I put in notes? Maybe not. Yeah, so you do write down in here. Now this is given in the formula booklet. If y equals 10x, actually 10kx, in the formula booklet is 10kx, then dy by dx equals k sec squared kx. So this is given in the formula booklet. This is given in the formula booklet. Right? So yeah, okay. So we can use a formula booklet. We don't have to prove it until they ask you, can you prove derivative of 10x is sec squared x? Then you have to show all that. But otherwise, you can use the formula booklet. Okay. Next one. What about sec x? Now, sec is, again, is given a formula booklet. You'll see at the below of the page or the next page, you will see that it's given a formula booklet. But what if they ask you to prove it? You know, then you have to show how to prove y equals sec x. Well, how do we do y over sec x? The only thing we know about sec x is 1 over cos x. And over cos x, we can, let me ask you, okay, what rule can we use in here? Okay, you got options, chain, no, product, and quotient. So pause the video, I will think about which rule can we use in here. Okay, so, well, clearly, fraction, we can use quotient rule. But that's not the easiest one, because the easiest one is actually chain rule. Well, how? We can write cos 1 over cos x as cos x to the power of minus 1. Remember, we've learned about the shortcut for chain rule. Shortcut for chain rule is to differentiate from the outside to the inside. So the derivative outside is power of minus 1. To differentiate power of minus 1, we multiply by the power goes down by 1. Times, like an onion, we differentiate inside, differentiate cos x is negative sine x. So then we can simplify. Minus makes a plus of sine x times cos x to the power of minus 2. So what can we do to rewrite this? We can write as sine x over cos x squared, which is same as sine x over cos squared x. So left hand side is dy by dx. We can do something about it because sine x equals cos squared x. We can write as sine x over cos x times 1 over cos x. Sine over cos is 10x. 1 over cos x is sec x. So the derivative of sec squared x for sec x is 10x sec x. Now, can I challenge you to do it on a separate paper, or you can do it on a paper as well? Try the quotient rule, okay? Try the quotient rule to prove that. Okay, try to use the quotient rule instead of a chain rule. All right? So, well, I'll challenge you and try to do it on a different paper. If you can't, come and ask me. Right, so these are given in the formula booklet, okay? To differentiate cosec x, sec x, and cot x, dy by dx equals negative k cosec kx, kx, so these are all given, okay? When you see cosec, sec, and cot, if you differentiate, use the formula booklet, right? This becomes your new Bible, dictionary that you read every day, newspaper, right? Or you may want to stick in the ceiling so you can see them every morning when you wake up. Right, so 9.6, differentiating trigonometric functions. Example, to differentiate this one, y equals cosec 2x over x squared. Anyone know how we can apply, how we can start differentiating? Quotient rule, fraction quotient rule. So we're going to apply quotient rule. So u is cosec 2x, v is x squared. du by dx. Okay, so let's read the formula booklet. Cosec 2x is negative k cosec kx cot kx. So negative k, negative 2 cosec 2x sec 2x. We'll just write down. Okay, we'll just have to follow it. And then dv by dx. Let me move this to the right. dv by dx is 2x. Quotient rule. dy by dx equal v du minus u dv over v squared, x squared x to the power 4. Okay. Well, what can we do in here? There's nothing much we can do apart from maybe writing a bit neater, but also we can divide every single term by x to simplify it maybe. And that's all we can do really. So I'm going to write a bit neater. dy by dx equal, so I'll write negative 2x cosec 2x sec 2x minus 2 cosec 2x over x cubed. Some of you might ask me, sir, can we not cancel out another x because there is an x in here, and x in here? Well, no, because these x's are inside cosec and sec. These are inside a trig. You can't cancel them out. If you have no idea what I'm talking about, imagine this. Can you simplify 1070 into, because 7 and 70 cancel with 10, can you do it like this? Of course you can't. Okay, of course you can't. So you can't cancel the x. Right, so next one. Okay, question B. Sec cubed x. Right, sec cubed x. Perhaps you can tell me what rule can we apply in here? So y equals sec cubed x. So it's either chain, product, or quotient. The answer is chain. Okay, sec cubed x because it's like an onion. We've got layers in there. All right, so we can write sec cubed x as sec x cubed. So to differentiate sec x cubed is chain rule. Differentiate from the outside to the inside. First, differentiate power of 3. So power of 3 means multiply by the power minus 1 times, open inside, you see a sec x, okay? Oh, you see sec x. And then you look at the formula booklet, the derivative of sec x is sec x tan x. So times sec x tan x. I'm going to simplify a little bit. 3 sec squared x times sec x tan x, which could be rewritten as sec squared times sec cubed x tan x. And yes, that's it. That's the end. All right. Your turn. Practice. Pause the video. Have a go at a question. When you're ready for the answer, you can press play. The final answer, mu is 6. Okay, the final answer, mu is 6. If you got it right, well done. Okay, move on. But if you don't, I'm going to go through how. Well, to differentiate sec squared 3x, this is a chain rule. Okay, so I'm going to write y as sec 3x bracket squared. Okay, so dy by dx chain rule. Again, chain rule. Differentiate outside to the inside. First of all, differentiate power of 2. So 2 bracket sec 3x to the power of 1 times differentiate sec 3x is 3 sec 3x tan 3x. Using formula booklet, sec kx is k sec kx tan kx. We'll simplify the terms. 2 and 3 simplifies to 6. Sec 3x, sec square 3x. And tan 3x. But that's not quite the same as the answer yet, because the answer has no sec in there. So we need to think about what's the link between sec squared or sec and tan. Identities. So we know 1 plus tan squared x equals sec squared x. So, yep, so we can replace sec squared 3x as, like this, 1 plus tan squared 3x and 3x. Okay, so this has become this. That's how we can change everything to 10. Then we can multiply a bracket. Well, so how do you do this? It doesn't look like a normal thing that we can apply. We can multiply. Well, think about this. I know it looks a bit weird, but let's think of this. If I do 6 times 2 times 3, okay, that's the same as 6 times 3 times 2, isn't it? So when you all multiply them, the terms could be rearranged. So in other words, I can bring the tan 3x in the front, like 6 tan 3x, 1 plus tan squared 3x. Obviously, this step is not required if you see it through from the beginning. So you can expand the bracket now. 6 tan 3x times 1, 6 tan 3x. 6 tan 3x times tan squared 3x, 6 tan cubed 3x. They want a constant to be outside, so I'll just factorize the 6 out. And that's the answer. Okay, 6 tan 3x plus tan cubed 3x. Right? Okay. One more example. Often, in exam questions, you'll be given x in terms of y, but you want to find dy by dx in terms of x. So the key is to make use of an appropriate trig identity, such as sine squared plus cos squared equals 1, 1 plus tan squared equals sec squared, and 1 plus cot squared equals cosec squared. Okay. Right, let's see how we can use it. Example, given x equals tan y, express dy by dx in terms of x. Now, you'll be thinking, okay, if I want to find dy by dx, surely I can make y the subject in here, can I? Because in the previous one, you can see we can make y the subject and we can start differentiate dy by dx. So what's the big deal? Here, smarties, let me tell you, if you try to make y the subject in here, let's see what happens. If you try to make y the subject, it's an incorrect one. It's not incorrect, but mathematically, there's nothing impossible. It's just difficult or easy. And surely you want to go for the easier route. So if we make y the subject in here, then you have to arc 10 on the left-hand side. That means you've got inverse 10 of x equals y. And little smarty, let me ask you, how do you differentiate 10 to the power of minus 1x? Sorry, not 10 to the power of minus 1x. Arc 10 of x. By the way, this is not the same as 10x to the power of minus 1. It's not the same because this equals to 1 over 10x. whereas inverse tan of 1 is the same as arc tan x. That's not the same thing, okay, smarties. So that's not the same thing. So how do you differentiate arc tan x? Well, it's not you can't, but I'm not going to go through here. It's usually a high level of maths for the maths, but we'll leave it in here. So we cannot, let's assume we cannot do arc tan x. We cannot differentiate arc tan x. So if that's not possible, we as a really resilient human being, if we can't go one route, we find another route. Okay, just like when you get to that jar of cookies. If I can't get it right now, I'll wait for my mom to leave and I'll go and get that jar of cookies. Right, anyway, so how do we do that? We'll do a dx by dy. Dx by dy. Okay, we differentiate normally, but in terms of, but this time we do dx by dy. Differentiate tan y. Well, using the formula booklet, we know the derivative of tan y is sec squared. So sec squared y. Right, so sec squared y. You should have a student tell me, oh, sir, is that not the same as a sexy? But anyway, yeah, if you want to be, if you think it's fun, you're fun, you know. Anyway, so then what do? We do dy by dx. Dy by dx, and flip it as 1 over sec squared y. Well, why? Because we need the dy by dx, so we flip on both sides. Okay. Then, however, we still have y in there. We want our answer in terms of x. So we need to use identity. Okay, we need to use identity. Y identity. First, if you want to make y to an x, we need to somehow make a connection between x and y because x relates to tan y. So somehow you need to bring this to a tan so we can start to relate to x. So I'm going to use the identity 1 over 1 plus tan squared y. Now I would like you to write down, okay, why do we do this step? I'll give you time to pause it, okay? Try to think of the answer. Why do we do? I explained it already, but you can write that. Why did we do this? Why do we apply the identity? So pause the video now, write it down, and when you're ready, press play. The answer is, I'll say again, if you're lazy, go back. It's because we want to make it so in terms of x, and the only relationship between x and y is through tan y. So we need to somehow change the sec squared into tan. And the way we can change sec squared into tan is through the identity 1 plus tan squared y. Okay, so 1 plus tan squared y, tan y is same as x. So we can now write 1 over 1 plus x squared, and that's done. Okay, so in here, plus x equals tan y. Therefore, x squared equals tan squared y. Right? Okay. Right, so now there's one example in here which is actually out of syllabus of normal maths. If you're not interested, you can finish the video now because that's the end of it. But since I put it in here, it was in there in the first year of the new spec back in 2018, but they removed it afterwards, very straight after. So if you're using the older textbook, you might see actually there's some older questions, there are some arc-sine questions in the textbook which will not be in the newer edition ones. So again, if you don't want to listen, feel free, move on. Okay, just go and do the question, do the homework. But if not, let's have a look together. Okay, so if you're interested, further mathematicians, you should know how to do this. If you do core PO2, you should know how to do this. Okay, if y equals arcsine x, so what do we do? Well, I'm going to show you. So y equals, I'm going to rewrite this. Okay, arcsine x as inverse sine of x. I bring a sine to the left hand side. So sine y equals x. Then what? Dx by, and then if I make x a subject on the left hand side, okay, it's like chips. You always have ketchup, subject on the left hand side. Dx by dy equals differentiate sine y is cos y, cosine. Then what? Well, if I flip it both sides, dy by dx equals 1 over cos y. I need to make, I know x and y has sine y equals x. That means I need to somehow make a cos y into sine y. And the way I can do it is use identity again. So dy by dx equals 1 over. Now in here, because sine squared y plus cos squared y equals 1. So cos squared y equals 1 minus sine squared y. Cos y, therefore, equals to square root of 1 minus sine squared y. And we can put it in there. And we know sine y is x, therefore dy by dx equals 1 over square root 1 minus x squared. And that's the answer. Okay. It's not, if only you're interested, again, you will not be tested on this. All right. And that's the end of 9.6, where next time we look at differentiating parametrically. So what you've learned today is differentiate. Apart from sine and cos, you've also learned two more things. One is using the new derivatives from a formula booklet about cos, cosec, sec, and cot, and also the one about tan y. Okay, and the second thing you've learned today is how to use sort of dx by dy and use identity, okay, backwards. And that's the end of the lesson. Thank you.